One of the most fascinating twists in our human story is this: modern Homo sapiens, biologically and physically just like us, have been walking the earth for at least 200,000 years. If you plucked one of those early humans from their world, gave them a haircut, dressed them in a hoodie and jeans, they could probably blend into a modern crowd without anyone giving them a second glance. But here's where things get strange. For most of those 200,000 years, not a whole lot happened. No cave paintings, no musical instruments, no elaborate burials, no jewelry, no clear signs of religion or mythology, and no real evidence of abstract thinking. Small bands of people hunted, gathered, and made simple stone tools, and that was about it. Then, roughly 50,000 years ago, something changed. Almost overnight, human creativity burst into life. We suddenly start finding cave art hidden deep in remote caverns, intricate beads, carved figures, and signs that people were making risky ocean journeys to reach distant islands with no land in sight. So what happened? Why did it take so long for humans to start acting, well, human? This rapid transformation, what scientists call behavioral modernity, has been one of anthropology's biggest mysteries. For a while, researchers thought they had the answer: a single genetic mutation that rewired our brains, giving rise to symbolic thinking, language, and culture. One gene, in particular, grabbed the spotlight: FOXP2. Discovered in the 1990s, FOXP2 was linked to families with unusual speech and language difficulties and was found to regulate other genes crucial to brain development. It looked like this might be the elusive human upgrade gene. But in 2007, that idea hit a major roadblock. A team led by Svante Pääbo sequenced the FOXP2 gene from Neanderthal DNA. And it turned out to be identical to ours. That meant FOXP2 couldn't be the magic switch behind the creative explosion 50,000 years ago. It's still important for speech, but it wasn't unique to us. Meanwhile, archaeologists were busy rewriting the timeline. In South Africa's Blombos cave, researchers found engraved pieces of red ochre, carefully scratched patterns, dating back over 70,000 years. Suddenly, it seemed human creativity hadn't appeared out of nowhere at 50,000 years ago. It had been slowly building long before we realized. Artifacts have since turned up dating back even further, some over 100,000 years old. Among these were shell beads with tiny drilled holes, likely worn as jewelry or to display social status. This wasn't just survival, it was identity, symbolism, and culture. At Pinnacle Point along South Africa's coast, early humans were heating stone to improve their tools and harvesting shellfish with a sophisticated understanding of tides and seasons. Some of this activity dates back 64,000 years, far older than the supposed Big Bang of human creativity. And there was more. At sites like Sibuta Cave, early humans were making plant-based bedding, using glue for composite tools, and employing red ochre for likely ritual purposes. At another site, painted ostrich eggshells served as water containers. These discoveries tell a powerful story. The dawn of modern human behavior wasn't a lightning bolt. It was a slow, steady build-up, with the famous 50,000-year mark representing a tipping point, not the start. So why did we miss these earlier signs for so long? Simple, because for much of the 19th and 20th centuries, most archaeological digs happened in Europe. And modern humans didn't even reach Europe until about 50,000 years ago. Archaeology exploded there, and naturally, early researchers focused on their own backyard. The earliest evidence of symbolic behavior, like French and Spanish cave art and German figurines, all came from this later European chapter. It's like assuming a band's first hit single was the first time they ever made music, when in fact, they'd been playing small gigs for years. But here's another twist: we weren't alone. For most of our history, we shared this planet with other human species, each with their own tools, customs, and evolutionary paths. And the more we learn about them, the clearer it becomes that we weren't the only ones capable of symbolic, creative thought. Take the Neanderthals, for example. They appeared around 400,000 years ago across Europe and Western Asia. Long caricatured as grunting, hunched-over brutes, modern discoveries paint a very different picture. Neanderthals built specialized tools, mastered fire, even using minerals like manganese dioxide to help ignite it, and survived brutal ice ages. They buried their dead, possibly with flowers, as seen in Iraq's Shanidar cave, where skeletons were carefully arranged over 65,000 years ago. Neanderthals were artists, too. In Spain's La Pasiega cave, red pigment markings date to over 64,000 years ago, long before Homo sapiens arrived in Europe. And in France's Pinnacle cave, a remarkable ring-shaped structure made from hundreds of broken stalagmites was built by Neanderthals roughly 76,000 years ago. Constructed deep inside a cave, in total darkness, it suggests intentional planning and perhaps ritual meaning. And Neanderthals weren't our only creative relatives. The Denisovans, discovered in a Siberian cave in 2010 from a single pinky bone, were an entirely different species. Their DNA survives today in people from Melanesia and among Australian Aboriginal groups, with up to 4% Denisovan ancestry. In 2019, a beautifully crafted green chlorite bracelet, polished and drilled, was found in Denisova cave, dating back at least 40,000 years. It wasn't made by us, but by Denisovans, and might be the oldest fine jewelry ever found. Then there's Homo erectus, humanity's ultimate long-distance runner. First appearing nearly 2 million years ago and surviving until about 100,000 years ago, they were the first humans to regularly use fire and likely the first to cook food. In 2014, archaeologists in Java uncovered a 500,000-year-old freshwater mussel shell engraved with a deliberate zigzag pattern, one of the oldest known examples of abstract art. These finds reveal something humbling: Homo sapiens didn't invent symbolic thinking, culture, or jewelry. We inherited them, as part of a long, tangled family tree where multiple human species evolved side by side. Sometimes they kept their distance, sometimes they fought, and sometimes they interbred, leaving pieces of their DNA inside us. If you have European, Asian, or Native American ancestry, you probably carry 1 to 4% Neanderthal DNA. If you're from Oceania, you might have up to 5% Denisovan DNA. Genetic evidence also suggests that around 70,000 to 80,000 years ago, a catastrophic event, likely the Toba supervolcano eruption, may have reduced the entire Homo sapiens population to fewer than 10,000 breeding individuals. Our survival wasn't inevitable. It was a lucky, precarious escape. For a long time, people imagined human evolution as a tidy ladder, with each rung a little smarter, a little taller, until finally reaching modern Homo sapiens at the top. But that's not how evolution works. It's a sprawling, branching tree, messy and full of dead ends, side paths, and comeback stories. Think of it like a skill tree in a game: different builds, strengths, weaknesses, and fates. Neanderthals weren't a failed version of us. They were Ice Age champions, perfectly adapted to Europe's brutal winters. If the environment hadn't changed, or if Homo sapiens hadn't wandered into their lands, they might still be here. Denisovans thrived in Siberia, passing on genes that help modern Tibetans live at high altitudes. Homo naledi, discovered in 2013 in South Africa's Rising Star Cave, had small brains but may have buried their dead over 200,000 years ago. Homo floresiensis, the so-called hobbits of Indonesia, stood only 3 feet tall but made sophisticated tools and survived in a challenging island environment. At various times, all of these species shared the Earth with early Homo sapiens. Sometimes peacefully, sometimes not, and sometimes interbreeding. Our story isn't a royal lineage of the chosen ones. It's a messy saga of survivors, innovators, and wanderers. So why did human culture explode around 50,000 years ago and not earlier? It wasn't about brain size or intelligence. It was about numbers. Even if one brilliant hunter or shaman came up with a new tool, idea, or ritual, it would vanish if there weren't enough people to share it with. Anthropologists call this cultural drift. When populations are tiny and scattered, knowledge is fragile and often lost within a few generations. For most of human history, our global population was astonishingly small, perhaps just a few thousand people at certain points. Some estimates suggest the number of breeding Homo sapiens on the entire planet once dropped below 1,000. But starting around 60,000 to 50,000 years ago, climate conditions stabilized, populations grew, and people clustered in resource-rich areas. Ideas could spread, be copied, and improved upon. Culture started to snowball. And here's the kicker: in 2009, researchers Powell, Shen Nan, and Thomas proposed that it wasn't a sudden brain upgrade that sparked human innovation, but demography, population density. More people, more connections, and more ideas bouncing around. This understanding reshapes our view of human evolution. It wasn't a straight march toward a final form, but a branching, improvising, unfinished story. And we're still here, still evolving, still telling it. And it's not over.